video, we're going to look at examples 7 through 12 dealing with solving trigonometric equations on it. Particularly, let's start with number 7, and we're going to kind of work our way up to different techniques, talk about the strategies on how to deal with it. In number 7, you're trying to solve for cosine. And when I say this is a pretty basic structure for us, is if I want to solve for cosine, I'm going to try and get that by itself. So I'm going to subtract the 1. And then, to get the cosine by itself, I'm going to divide by 2. So there is where cosine of x equals -1/2. I've isolated the object I've solved for. And at this point, what you would do is you would go to your trig chart and you would see where is the cosine of an angle equal to -1/2. And that's going to give you your answer. What I like to do is I like to go through and think about where are my values positive and negative for all my trig ratios, which is this chart. The all students talk constantly is all of them, all trig ratios are positive in the first quadrant, only sine in the second quadrant, tangent in the third quadrant, and cosine in the fourth quadrant. And the reason why this is helpful is I can see my cosine is -1/2, which means that I'm going to be in the second quadrant somewhere, and I'm going to be in the third quadrant somewhere, because the first and fourth quadrant is positive. So when I go to my trig chart, it kind of gives me a place to look. So where is cosine of x equal to -1/2? And in the trig chart, that's going to be 120 degrees and 240 degrees. And there's our answer. So we're going to kind of pause and think when we solve to figure out where our values are. And we want to isolate our trig ratios, treat them like objects. So in this case, really straightforward, similar to a linear solving. But then we go to one like number 8. And this one's not as straightforward. But what I'm going to keep in mind, number 8, is a few things with the structure. Right away, I see I have a cosine squared. And a flag that comes to mind when I do this is when I see a squared, I'm thinking there's a chance I'm going to factor. Not guaranteed, there's a chance. Well, when you factor, you want to set it equal to 0. And in this case, it's not equal to 0, it's equal to cosine of x. So I need to figure out how to get it equal to 0. Well, the first thing I would do is I would subtract the cosine of x. That's going to give me cosine squared of x minus cosine of x equals 0. Now, how do I solve this? At some point, your factoring skills need to improve when you're dealing with trig ratios. And one of the easy ways to get them to improve is to kind of think of your cosines as variables. So I'm going to replace cosine of x with a. And I'm going to do the problem on the right side. If I have a squared minus a equals 0, what I would do is I would apply my GCF technique. I would see they both have an a in common, so I'm going to factor an a and left a minus 1. And the same thing is going to be over here with the cosine squared of x minus cosine of x. These have a GCF as well of cosine of x. So I can factor that out. And notice the structures are the same. I have an object on the outside, I have an object on the outside. I have an object minus 1, I have an object minus 1. So the way I factor with a's is going to be the same way I factor with cosines. So how do I keep on going with the right-hand side? Well, when you're factored, what you do is you set each factor equal to 0, and then you would solve. Well, it's no different with cosines. I'm going to set each one equal to 0. And then I'm going to solve. So if cosine of x equals 0, there is no solving. I automatically know cosine of x equals 0. So I'm going to go to my trig chart, and I'm going to see where is my cosine of x equal to 0. And that's at 90 degrees and 270 degrees. For the next one, cosine of x minus 1 equals 0, I'm going to add 1. So cosine of x equals 1. Now where on my trig chart is the cosine of x equal to 1? And that's going to be at 0 degrees. Now, because it's me, I like to put my angles in numerical order. So 0 degrees, 90 degrees, and 270 degrees. Those are the answers to the problem. So we started off basic with number 7 with a linear, and then we went straight into factoring with number 8. What you need to get down is how do I factor, how do I factor? And the idea is start looking at them, they were variables. And if it helps you to write it down, then write it down first. And notice the structures are the same for solving. So let's take a look at number 9. And again, how do we do number 9? Well, I notice it's equal to 0. That's nice. And I see a squared. So same idea. If I see a squared, I'm going to think factor. It's already equal to 0 for me, so that kind of helps me out. My job next is to figure out, well, how do I factor? Well, there's a bunch of signs there, sine squared. I struggle with that, so let me try and do this. Let's replace sine with a. Is maybe if I can factor 2a squared plus 3a minus 2 equals 0, maybe if I can factor that, I can apply those same techniques to sine. And so let's see what happens. In this case, you have your AC method of factoring. You would do a times c, and I would get negative 4. So what number is multiply negative 4 and add to 3? And in that case, I'm going to have 4 and negative 1. So what we do with the a is you would split this 3a into 4a minus 1a. And you would leave this 2a squared. Then you would do factoring by grouping. You would see the first two have a 2a in common, and you'd be left with a plus 2. And you would see the second two have a negative 1 in common, and you'd be left with a plus 2. And then lastly, what you would do is finish the group. They have an a plus 2 in common, factored out, and you're left with 2a minus 1. And you may ask yourself, why do we do this entire problem when I really want to do that problem? And it's because your techniques are exactly the same. If I can solve with a's, there's no reasons why I can't solve with sines. It's going to be the same technique for it. This is an AC method of factoring. I would do a times c. And if I do a times c, I end up with negative 4. Middle term is 3 sine of x. I want them to add to 3. So what two numbers multiply negative 4 and add to 3? And in that case, I get 4 and negative 1. And that's how we split this. So how do I use that for sine? Well, I have 2 sine squared of x. And I'm going to split into 4 sine of x minus 1 sine of x minus the 2 equals 0. So notice the splitting that we did. It's the exact same. Instead of 4a minus 1a, I have 4 sine of x minus 1 sine of x. And we keep going. If I want to do grouping, the first two have in common a 2 sine of x. And I'm left with sine of x plus 2. The second two have a negative 1 in common. If I factor that out, I'm left with sine of x plus 2. And look side to side as we're going. Do we see that our structures are the same as we're moving? Twice an object, twice an object. An object plus 2, an object plus 2. Minus 1, minus 1. An object plus 2, an object plus 2. So structurally, they are the same factoring techniques. So that kind of helps me out with the next part. Is as I finish the factoring by grouping, I see these both have a sine of x plus 2 in common. And if I remove those, I'm left with 2 sine of x minus 1. And look at our answer compared left to right. They look very similar to each other. So let's finish solving. Set each one equal to 0, so 2 sine of x minus 1 equals 0. You would at first add 1 and then divide by 2. So in this case, I see sine of x equals 1/2. So I'm going to go to my trig chart. And again, think just in general about where is sine positive. Sine is positive in the first quadrant and it's positive in the second quadrant. So in this case, you should get 30 degrees and 150 degrees. Now when I do the next one, now pay attention to this because we didn't have an example like this on the notes, is sine of x plus 2 equals 0. Now if I solve for this, I get sine of x equals negative 2. And that's not possible. And so we kind of ignore this. Now if we want to remember why it's not possible, let's think about the idea of where sine values work. And it's the idea of the unit circle. Is the radius is 1 for the unit circle. So like here, the sine is 0, the sine is 1, the sine is 0, the sine is 1, is you can't go beyond negative 1. Is your range for sine functions is between negative 1 and 1. So therefore, I can just throw that one away. That one's not needed. You don't have to take into consideration. We're not dealing with imaginary. These are our only answers for that problem. So two important things with this one is your AC method of factoring and the idea of throwing away if it's not within the range of the sine functions. But I want you to see how step by step they are the exact same for us. The structure is similar each time you go through with factoring. And I think that's important to kind of give yourself some confidence in your ability for this. So I didn't grab everything there. We're going to look at number 10 next. So let me just give myself some room. Shrink this down. There we go. Now number 10. What's different about this one compared to the other one is I see a sine of x and then I see a cosine squared of x. And what I don't like about this is we don't have the same terms. I can't do anything if I have a sine and a cosine squared. Is I want similar. You would use the word variables, similar terms, like terms, and I'm going to say I want similar objects, which is the same idea as I want like terms. And the problem is I can't change sine into cosine. That's not going to happen. But what I can do is I can change cosine squared into sines. And the way I do that is by using my Pythagorean identity. We refer to it before doing it in reverse. So I have sine of x equals 1 plus. And we know from our Pythagorean identities that cosine squared is 1 minus sine squared of x. And so what I'm going to do is now I have similar objects. And that is awesome. I have like objects. I can keep going. But the problem is, what do I do from here is I see squared. I'm going to factor. I'm going to set it equal to 0. Now for me, I don't like factoring with a negative square term. So what I'm going to do is I'm going to add the sine squared, which is going to put it on the left side. I have the sine of x. Now these two are like terms. They're going to combine to 2. And so in that case, I'm going to subtract 2. And maybe I kind of rushed through that. Hopefully you can start imagining the objects sliding back and forth for the solving. If not, I'll kind of give myself one more line here just to make sure everyone follows. Sine of x combined, I get 2 minus sine squared of x. And that's where I subtracted the 2, subtract 2, add the sine squared of x, and add the sine squared of x. And now you can kind of see the structure. Well, how do I go from here is similar. Is how do you factor with trig ratios is the same way I would factor if it was a's. If I had a squared plus a minus 2, I would find out what multiplies to negative 2 and adds to 1. And that would be 2 and negative 1. And so the factoring here is going to be the same idea. I'm going to have sine of x plus 2. And I'm going to have sine of x minus 1. Same format for solving. Set each one equal to 0. First, I get sine of x equals negative 1. Which remember, you can't go beyond negative 1 or 1. So I can throw that one away. Sine of x minus 1 equals 0. See sine of x. And for me, that only occurs at one spot. It's where x equals 90 degrees. And there's your answer. Now the factoring, maybe I talked too fast through it. Hopefully by staying on this part of the window, you can kind of think through the process of what multiplies into 2 and adds to 1. And that's how I did it. But the idea here wasn't primarily factoring. The idea here for this example was doing the reverse of the Pythagorean identity in order to get similar objects, or what you refer to with algebra as to get like terms. And once I do that, I see I have to set equals 0 because of the square. And I know I'm going to have to factor, and I factor with positive square terms. So this one goes through, and again, notice it has another domain issue just like number 9 did for it. So that's popped up a couple times, something to keep in mind for us. Let's look at number 11. So what do I see about number 11 is I have a cosine and a tangent. Well, it's just like number 10. I'm going to need, in a way, I can't do any factoring here, so I'm going to need like terms. So what I'm going to do is I'm going to change tangent of x into sine of x over cosine of x. And what that's going to do is that's going to allow me, since it's all multiplication, to cancel out the cosines. So all I have is sine of x equals half, which if we think about, it's going to be positive only in the first quadrant and the second quadrant. So when I go to my trig chart, I'll see x equals 30 degrees and 150 degrees. And there we are. Those are our answers. That one's pretty straightforward, and well, this idea of 5-1 with simplifying with trig identities is, in this case, to get a like term, I'm going to have to change it. There's no factoring involved. So we notice how we're building is kind of seeing some repeating themes of like terms, and I bet you in number 12, do we have like terms? And this one's going through is, do I change everything to sines? Do I not change everything to sines? Do I change the cosines? How do I know? Well, if I'm stuck, what I'm going to do is I'm going to imagine their variables. So instead of sine, I'm going to use A. And instead of tangent, I'm going to use B. So really it's the same as that. AB minus A equals 0, sine of x, tangent of x, and sine of x equals 0. Same format for structure. Well, if I look at this, how do I solve? Is I'm going to take out a GCF. They have an A in common. And if I take it out, I'm left with B minus 1. So notice my variables now are separate factors. That is crucial for solving. Is together we can't solve. If we pull them into separate factors, we can't. So it's actually the same idea here. These have a GCF of sine of x. So I can factor out a sine of x, and I'm left with tangent of x minus 1. And so notice our trig ratios are pulled away from each other. We can now solve. I'm going to set sine of x equals 0. And if sine of x equals 0, using our trig chart, we know that occurs at 0 degrees and 180 degrees. If I have tangent of x minus 1 equals 0, I would add 1. And so if I think about my quadrants where it's positive, all of them are positive here. So that means I know I'm going to have 1 in the first quadrant. Only sine here, and tangent's positive down here, cosine here. So my answers are going to be somewhere in the first quadrant, somewhere in the third quadrant. When I go to my trig chart, I know where to look. And those, for this case, would be x equals 45 degrees and x equals 225 degrees. Again, it's me, so I like to put everything in numerical order. And there are the answers. Our 0, our 180, our 45, our 225. So this is just meant as a way to kind of help our confidence when dealing with solving. It's meant as a way to see the different techniques. Notice on a lot of these, so we had 6 examples, is when I got stuck on what do I do, I looked at what would I do if it was a variable instead of a trig ratio. And that allowed me to figure out all the different solving techniques. when I had to factor. Even it allowed me to make AC method a lot easier so I could see step by step what to do. So that is a really important concept, is how do I factor with trig ratios? And then we also learned is how do we pull out with GCFs? So hopefully this helped you review the 5-5 concept that we learned before.